Okay, so what we're going to look at now is the fundamental theorem of algebra, but we're going to kind of look at the second part. We've already talked about the first part, which tells us that the leading exponent, or the leading degree, tells us how many solutions there are in a polynomial. What this part's going to do is it's going to help us narrow down what the solution to that actually is. Now when we talk about solutions to a polynomial, we are talking about the roots or the zeros, or wherever that graph would cross zero. The x-axis. Anywhere that graph will cross the x-axis. Now there's going to come times when that graph does not cross the x-axis, and that's going to give us complex roots. The nice thing about complex roots is that they always come in pairs. So if you get one of them, you always have a second one as well. Now you don't always need to have complex roots, but at certain times you will find that you do have complex roots. And depending on the degree of your polynomial tells you how many possible real and complex roots you can have. If I've got a degree of 1, that means I can only have a real solution. If I've got a degree of 2, that means I can have 2 real solutions, or I can have 2 complex roots. Because remember, those complex numbers come in pairs. If I have a third degree polynomial, I either have 3 real roots, or I have 1 real root and I have 1 pair of complex roots. For degree 4, I could either have 4 real roots, or I could have 2 real and 2 complex, or I could have 4 complex, and it's going to continue on in this pattern all the way down. So that's the first thing we can come up with, is how many solutions we have. The second thing we can come up with is how many real solutions we may have and how many complex solutions we may have. And if I'm looking on here, I can use some tools to find what the zeros are of the polynomial. So the rational zero test tells me that if I have some sort of polynomial and it's got coefficients where the leading coefficient is not a 0 and that constant, or the last term, is not a 0, then any rational zero will be some sort of combination of p over q, where p is a factor of my constant and q is a factor of my leading coefficient. And now if they are imaginary zeros, it's not going to hold kind of the same value. It's not going to hold true for imaginary zeros. But if we start with an example and we can work this all the way through, it'll kind of give us a clearer message of what we're talking about here. We have a polynomial here with a leading degree of 3, which tells us we're going to have 3 solutions. Now those 3 solutions, they could either be 3 real solutions, or they could be 1 real and 2 complex. Okay, so now we have an idea of how many solutions we have. We also have an idea of the possibilities for those solutions. Now we want to kind of narrow down if, in fact, well, in this case, we do have to have at least 1 real solution. Let's find what those possibilities for that real solution are. And we mentioned something about a p and something about q. Now these 2 numbers come from my coefficient of my leading exponent. In this case, it's pretty simple. It's just going to be q is a 1. And my leading my constant is a 5. We can disregard that negative sign up there for now. Again, these are easy ones because if we factor these out, 5 only has factors of 1 and 5. 1 only has factors of 1 and 1. And now we talked about the possibilities are going to be any factors of p over any factors of q. So this one's going to say, we could start with p, we could use 1 as our leading factor. So our real number could be 1 over 1. And we have to include our positive and negative here, because it could be a positive 1 over 1 or a negative 1 over 1. You can see if I use 1 over 1 for this one, if I use it again here, I'm going to have the same answer, so I don't have to repeat that. So that's all I have for the 1. And if I look at my 5, I'll do the same thing. I will have a 5 over 1, which is this one, and you'll see same thing if I use that one. So my possible answers for my real solutions are positive 1, negative 1, positive 5, and negative 5. And now, it's interesting because it's such a complex theory and there's so much going on here, but really all it does is limit down what your possible answers can be. So it tells us that we have 3 solutions. We know that for a fact. Those solutions can be either 3 real solutions or 1 real solution and 2 complex solutions. So it narrows it down as to what our answer should look like. It also tells us, in this case, we will have at least 1 real solution. So it tells us that real solution is either going to be positive 1, negative 1, positive 5, or negative 5. So it takes our answer from being any number in the universe to boiling it down to just a combination of those factors or complex numbers. So at this point, the fundamental theorem of algebra kind of just allows us to reduce the possibility of our answers. And as we continue along, we'll be able to solve for these polynomials and actually come up with correct answers and roots for our polynomials.